Welcome to the second part of chapter pressure. Welcome to my online class. Today we will mainly discuss about Upthrust Archimedes principle, a law of flotation, and some applications of atmospheric pressure. Uh, Now let's see Upthrust. And in the previous class we have learned that pressure equals to SdG. Pressure in the liquid is SdG, and we can see here. This is a box. I have made a box over here, and the pressure acts in all the direction from this side, from this side, from this side too. This is water is over here, and from this side also. Now this lateral pressure, sidewise pressure will cancel because the height is same. So this pressure cancels with each other. What happens actually in the above and lower pressure, since the height is S2 over here, height is less, so this height is more, or you can say depth. Always we calculate height from reference point. This is our reference point. I have made a reference line over here, so I am drawing it out. This is the reference line. So since this height is less, so pressure should be less over here and pressure should be more at the bottom. So I have written here P2 pressure is less than P1. Also pressure means force by area. So what you can say, F2 by, since the base area is same over here, okay, the base area is same over here, so F2 is greater than F1. So we are concluding one thing over here. Why? Because P2 means F2 by A2. We can just write F2 by A. Why? The area is same, F2 by A, and the same sign less than F1 by. You can see in the figure where is F1 and where is F2. Because since the base area is same, this A and cancels out, so we got this conclusion. So one conclusion we draw here is more force is acting downwards and less force is acting towards down. So what we conclude is F2 minus F1 is the net resultant force that is acting upward, and we call that force as upthrust. I hope you understood. Overall, if this is the mass and if it is kept in the liquid, F2 minus F1, yes, it is acting, okay, F2 minus F1. Now something is missing over here. F2 is greater than F1. Yes, it is correct. Now see, F1 minus F2. It should not be 1. It should be F1 minus F2. Since F1 is greater. Okay. Now see over here, this force is acting upward. So if you keep the solid in a liquid, then the liquid will push the solid upward by a force F1 minus F2. This value is called upthrust. I hope you understood. Upthrust means it is pushing upward. Also you know that if this has 5 kg mass, then 5 Newton force act downward. Let me change the ink. Okay. Be calm and again listen to me. If it is 5 kg, then 5 kg will act downwards. So if you keep this whole system in a liquid, then liquid will give upward force. Liquid will give this much force. You can calculate this value F1 minus F2, or loss in weight is also called upthrust. Okay, you can also find the value of thrust in this way. Pressure equals to force by area. Pressure equals to SdG. H means generally height, D means density of liquid, and G means acceleration due to gravity. If you compare 1 and 2, you will get F by A equals to SdG. So F equals to AHD into G. You know that D means density of liquid. Don't confuse with D means density. It means density of liquid in which you are keeping the solid. Okay, from here area into height, generally AH generally we mean that it is volume. So generally upthrust F, we can say F or U as upthrust. And what is the value of upthrust? Upthrust equals to volume immersed into density of liquid into gravity. I have mentioned over here in clearly. From this equation it is clear that upthrust depends upon the volume immersed, the volume which is inside the liquid. And next is density of liquid and acceleration due to gravity. mainly upthrust depends upon. And another thing, it is clear that upthrust means the force that object will come up, and this force is given by the liquid. And I have make your idea. Upthrust depends upon the volume immersed, upthrust depends upon the density of liquid, and upthrust depends upon the accretion due to gravity. Now obviously, last time I have done this one. If this is water bottle and you are carrying to moon, what happens to upthrust? Yeah, if you keep a solid inside it, what happens to the upthrust, to this solid? So upthrust depends upon the accretion due to gravity. If accretion due to gravity decreases, upthrust will also decreases. And density of liquid, if you keep the object in more denser liquid, then there will be more upthrust. It means if more upthrust, the object will come up. Yes, now I hope it is clear. I haven't told the definition, but it is clear that if this is a liquid, if you keep any solid over here, now a force, and all this is a liquid, and now upthrust is a force which is given by the liquid to the solid in upward direction, vertically upward. This force is called upthrust. Yes. Uh, Now this value, how upthrust is created is due to difference in pressure, P2 minus P2. Here the pressure value and here the pressure value are different, so we got the value of upthrust, that is difference in force. Now I told how on what factor upthrust depends. Three factors: volume immersed, the volume must be immersed, the immersed part of object, and next density of liquid, and gravity. Density of liquid, don't say density only, density of a liquid. Okay, yeah, what is upthrust? Now simple definition I have to: when an object is kept in a liquid, the liquid experience force to the solid in upward direction. This force, upward force, is called upthrust. Okay, now see, this is a solid object and it is kept in the air. Yes, and it is kept in the liquid. Now what happens? This liquid creates some sort of force to the solid in upward direction, that is called upthrust. So when an object is kept in a liquid, the liquid exert upward force to the object. This upward force is called upthrust. I hope now it's clear. Now I am going to demonstrate here, just by looking at the figure. See, this is the spring balance. Generally spring balance helps to measure the weight. Spring balance, SPRING, spring balance, this generally measures the weight. And pen balance means that measures the mass, and if you measure the mass, multiply by g to get weight. If your mass is 5 kg, your weight will be 5 into, if a mass of a stone is 5 kg, and its weight will be 5 into g, or 5 into 10. Okay, if you get the mass, multiply mass into g, and you will get the weight. I have told this in earlier class too, because these all things are necessary. Now see over here, object is kept over here and it's weighted, and weight is found to be 10 Newton. Now let us think deeply that where is this object in air? Does air give upward force? We say it's negligible. So if you want to find the real weight, we should weight in the air. Okay, here some liquid is over here. Liquid is here. I am writing here liquid. Some liquid is over here. Now let's measure the weight, and what we got, 8 Newton. Why we got 8 Newton? The same stone is taken here, but we got 8 Newton, and we believe that its weight should be 10 Newton, but we got 8 Newton. It means that some force is pushing it upward. Let me change it because it is red over there. Some force is pushing this stone upward, so we got less weight. And if some liquid is pushing the solid upward, that we call upthrust. And what is the value of upthrust? Weight in air minus weight in, yes, upthrust equals to loss in weight. We understood this one. And upthrust equals to weight in air minus weight in liquid. Weight in air is 10 minus weight in liquid is 8 Newton, so 2 Newton. 2 Newton force is applying upward. That's why we got the resultant force 8 Newton over here. I hope you understand. Okay, I have taken one video, and this is this video is given by Ministry of Education, and science teacher who teach in government school in Nepali medium is showing this one. So I thought this might be helpful to you. Okay, all of you look at this video.
जोखेर हेरौँ कति न्युटन पायौँ हामीले यसको तौल से 0.75 न्युटन पायौँ। यसलाई एक्ज्याक्ट हेर्न सक्छौँ हामी कति पायौँ त यसको तौल पाइयो 0.75 न्युटन, केजीमा चाहिँ यो 75 ग्राम।
Okay, he has shown the mass of the stone. Okay, this is the spring balance, and he told the mass and weight both. Just multiply by 10, you will get the weight. Okay, now he will take this stone in a liquid, and he measures the weight again.
यसको तौल कति हुन गयो 0.50 न्युटन। भाइ बहिनीहरु स्पष्ट हामी देख्न सक्छौं यसको तौल तरल पदार्थमा कति देखिएको छ त 0.50 न्युटन।
Okay, we observe here there is a loss in weight. So while measuring in air 0.75, and while measuring keeping in the water he measured 0.5. So there is a loss of weight of 0.25 Newton, and that's we call upthrust. It means that the liquid is pushing the solid up by that force. Also what we can say is, okay, I hope you understood this also. The same thing I showed from that video to make you more understand. Okay, now see here, this is a water, and if you keep solid over here, okay, if you keep solid over here, obviously the volume will raise till this one. So liquid will be displaced. Just we found here volume of liquid displaced. Now if volume of liquid displaced is known, then you can get the mass by volume into density equals to mass equals to volume into density. So just you can get the volume into density, volume of liquid displaced we can see, and you will get mass, and if you multiply mass by g, then you can get the weight of liquid displaced. Yes, you are getting the value of weight of liquid displaced. And this is not the way we find out experimentally. How do we find experimentally? See, the level of liquid is here. Okay, the level of liquid is over here, and if you keep the solid over here, what happens? The displaced liquid will come this side. So we'll take here a pen balance. Okay, pen balance. We'll take a pen balance and we'll measure the mass. And what mass you will get, you multiply by g. You will measure the weight of the liquid displaced, or also we call why this liquid is displaced due to upthrust. Okay, so I hope it is clear that from here, if you calculate the value of upthrust means generally loss in weight. Yeah, if you measure in air and in liquid, there will be loss in weight, that is called upthrust, will be equals to weight of liquid displaced. Okay, in the same experiment, if you keep the solid in if you keep the solid in a vessel full of water, some water will come out, that is called the displaced liquid. Okay, just you can see over here.
तरलमा जोख्दाखेरि यो तरल त पोखिन्छ नि, ए पोख्यो, हामीले देखिसक्यौं पोख्यो। ओ अब कति पानी पोख्यो त भन्दा तरल पदार्थमा यो ढुङ्गाको तौल जति घट्यो त्यति नै तौल बराबरको पानी पोखियो।
So from here it is concluded that the upthrust equals to weight of liquid displaced. Upthrust equals to weight of liquid displaced. I hope it is clear that I have done a lot of things in the upthrust. On what factor does upthrust depends? Volume emerge into density into gravity, acceleration due to gravity. And why upthrust created? Because if you keep in the liquid, the lateral pressure is same, but this force and this force will be more because due to depth, pressure will be more, area is same. So the more value of force is at the bottom. That's why we got difference in force, and which creates upthrust. It means that if you keep solid in a liquid, the liquid will push the solid upward. Yes, and this is the formula we derive of thrust equals to volume immersed into density of liquid into acceleration due to gravity. Yes, what is upthrust? Now it is clear that the upward force given by the liquid to the solid is called upthrust. Yes, here is 10 Newton. We can get 8 Newton. This is overall force net. Why we got 8 Newton? This the same stone is weighted over here because upthrust is giving some force towards in upward direction. Now let's go down. We learned that here upthrust equals to weight of liquid displace. Now let's do some questions. See here, an egg is here and egg is here, A and B. Study the figure in state in which liquid there is more upthrust. Okay, see this egg is floating, so we think that there is more upthrust. Why? Okay, because this liquid is pushing the egg upward. So why the liquid is pushing the egg upward? Because there is more upthrust. So the egg is floating over here, and there is less upthrust, so egg is sinking. Now, in which liquid A or B density of liquid is more? We know that if both are kept on the earth surface, G will be same, and volume immerse at first both are immersed equally. Upthrust depends upon the density of liquid. Upthrust depends upon the density of liquid. So salty water has more density. So we can say that A is a pure water and B is a salty water. So B has more density, hence more upthrust. So the egg what on the water. You can say that one also. This is the reason. If the density of liquid is more, upthrust will be more. Hence due to more upthrust, it will float. And similarly, you can say why it will sink. Because the density of liquid is less, upthrust will be less, hence it will sink. Now here, a person measures the weight in the same way. Okay, in the same way, and he measures the value using spring balance. Person measures the weight of a stone in different medium. He okay he took okay I want to make this one, and this is a mass of stone, and this is I think this is the spring balance. Now he took in different medium, and how much net weight he got? He got 15 Newton in medium A and 20 Newton in medium B and 17 Newton in medium C. Identify which medium is air, water, and salty water. Now you should identify as three medium. This question seems a bit interesting. How do you identify three mediums with region? Yes, within that air has less of thrust because air gives less of thrust. That's why weight should be more. Let's go to the previous video. Okay. See over here, I have made here the weight should be more because it is in air and in liquid generally weight should be less. And also, if the density of liquid increases, then upthrust should also increases. If upthrust increases, this resultant weight will decrease. If you feel a bit confusing, I can say that if density of liquid increases, upward force upthrust will increase. So net weight, or you can say net weight or net weight will decrease. So now with that logic we can answer over here. Yes, uh, 15 Newton, 20 Newton, 17 Newton. So medium B should be air. Air means medium B, and salty water is more denser. That's why C should be water. C should be water, and A should be salty water. Why? Because density is more, so upthrust will be more, so net weight will be less. This is the reason. That reason I have mentioned over there. Uh, what is the value of upthrust in water? Yes, upthrust equals to loss in weight. Upthrust equals to weight in air minus. Okay, I am writing just W1 minus W2. Weight in air minus weight in liquid. Question is asking about water, so weight in water. So what is the weight in air? We know that is 20 Newton. yes, 20 Newton minus 70 Newton, 3 Newton. You got the value of the in water is in. What is the value of weight of liquid displaced in salty water? Okay, this is in salty water. Weight of liquid displaced in upthrust are same. I have shown the earlier video also. Weight of liquid displaced and upthrust is same. That's why upthrust equals to what is the value? Okay, W weight in air minus weight in salty water. Weight in salty water. So you got the value over here. 20 minus 50, 5 meter. So this is the upthrust in water, this is the upthrust in salty water. 15 you will get 5 meter. Okay, 5 meter. Now let's go down. I hope you understood, and this is the famous question asked many times in the exam. Yes. More depth understanding on upthrust and leaping to Archimedes principle. Yes. Now see here, this weight is over here. It is not depth, and if you deep inside it, and some will come out, and this vessel generally we call overflow can or eureka vessel. And out is written over here. You can say outlet over here, and here we are using pen balance, and this is called spring balance. Now if you measure the weight, and if you deep inside the water, if you measure the weight will decrease. So overall, and generally this pen balance measures in the kg, so you can multiply by g to get weight. Now question number, let's solve question number. Name A, B and C. What is written? Where is A? This vessel is called overcurrent vessel A, and where is B? B is called spring balance, and C is called pen balance or top pen balance. Yes, it helps to measure the weight in displaced liquid. Displaced liquid, because if you keep the solid over here, the liquid will flow here. If you don't keep the solid, it will not flow over here. Yes. Now what is the value of liquid displace? Yes, liquid displace means what is the value over here. So 2 Newton is written, so liquid displace value is 2 Newton. Write over here 2 Newton. Or they might write over here 0.2 kg. Then you should multiply by g to write the liquid displace value, because weight of liquid displace. What is the value of upthrust? Upthrust is equals to weight of liquid displace. So upthrust generally means it should be same. So 2 Newton. Upthrust equals to weight of liquid displace. I have verified in the above. And what is the weight of object in the solid? Weight of object in solid, weight of object in liquid is 10 Newton. It is given clearly. You can see its value is 10 Newton. Now what is the weight of object in air? Weight in object in air minus weight of liquid. This is called, this value equals to upthrust. We have learned this formula, loss in weight. Generally weight in air minus weight in liquid. We don't know the value of weight in air, so keep here WA as it is. I have written here small a to note that it is in here. And what is the value of weight in liquid? It is 10 Newton. Now what is the value of upthrust? It is 2. Now weight in air is 12 Newton. Okay. Just addition of 2 you will get 12 Newton. So also one thing is weight in air should be more, so it is more than 10. And this what happens when the object is of W4 and density of liquid is increases. Okay, when the density of, when this density will increase, upthrust will increase, so weight will be less. Yes, weight will be less. This weight should be less, so this W4 should increase. Okay, because upthrust is more. This generally means, this W4 generally means value of upthrust also. So if density increases, upthrust will be more and this W2 will decrease. So yeah, just say W4 it should increase. Now state the law, Archimedes principle, and state the law. Yes, I think we concluded from here. Upthrust equals to weight of liquid displace. So we have written many times. That is called Archimedes principle. Okay, let's go down. Okay, it's written 25 minutes. Okay. Archimedes principle states that when an object is kept in a liquid, or you can say when this object is kept in a liquid, it might be partially or completely immersed. When an object is partially or completely immersed in a liquid, it experiences upthrust, which is equals to weight of liquid displace. So overall, Archimedes principle is upthrust equals to weight of liquid displace. So we use more word in explaining upthrust. When an object is completely or partially immersed in a liquid, in a fluid or liquid, it will experience upthrust, which is equals to weight of liquid displace. I hope you understood. The main thing in Archimedes principle, you can write Upthrust equals to weight of liquid displaced. Upthrust loss in weight and displaced liquid is called Archimedes principle. Now let's move to an Archimedes principle is applied both in solid and both in liquid and gas. It is applied both in liquid and gas, but in case of law of flotation, it is applied on liquid only. And law of flotation is a special case of Archimedes principle. A body will float when weight of object is equals to weight of liquid displaced by it. And also, you know, from Archimedes principle, upthrust equals to weight of liquid displaced, but the law of flotation says that weight of object should be equals to weight of liquid displaced or upthrust. So how much weight you are keeping on the liquid should be equals to weight of object should be equals to weight of liquid displaced. Okay, now body floats when the weight of object equals to weight of liquid displaced by it. So Archimedes says weight of liquid displaced equals to upthrust, but law of flotation says if weight of object is equal to weight of liquid displaced, it will float on the surface of the water. Now see here, weight of object equals to weight of liquid displaced. I have told many times, and weight generally means mass of object into gravity, and here mass of liquid displaced into gravity. Generally, weight of liquid displaced is also called upthrust. Upthrust means volume immersed into density of liquid into gravity. So I have written mass of liquid displaced, volume immersed into density of liquid. I have idea weight of liquid displaced equals to upthrust, so volume of immersed into density of liquid into access into gravity. Also mass equals to volume into density. We know that formula. I have written many times. Yes. Now let's go over here. Mass of object means MO into volume of mass of displaced. So VO generally mass means volume into density. So volume of object into density of object equals to volume of immersed into density of liquid. This might be a useful formula to solve numeric problem. Okay, in case of floating. Now, which object will float? And you might get one question. Iron float on mercury, but it sinks on water. Why? Because the reason, one of the reason is density of object should be less than density of liquid. So if the density of iron is more than the density of water, so iron will sink on water. But the density of iron is less than density of mercury, so it will float on mercury. That might be one of the answer. This also give you the one answer. If density of an object is less than density of liquid, it will float. Similarly, why the wooden cork will float? Because the reason is same. The density of wooden cork is less than the density of water. So similarly, why that rubber will float? The reason is this one. Okay. Now let's go down. What is the weight of floating objects? Okay, now I think I should again show you. Okay, now you can see the verification of law of flotation. Now
यो काठको टुक्रा भाइ बहिनीहरू अघि हामीले ढुङ्गालाई जोख्यौँ यो ढुङ्गा थियो यो ढुङ्गा हो यो चाहिँ काठको टुक्रा हो है यो ढुङ्गा हो जुन आर्किमिडिसको सिद्धान्तलाई भेरिफाई गर्नको लागि चाहिँ प्रयोगद्वारा सिद्ध गर्न चाहिँ हामीले डुब्ने वस्तु ल्यायौँ पूर्ण रूपमा डुबोस् या अलिकति केही अंश मात्रै डुबोस् डुब्ने नै वस्तु चाहिन्छ तर प्लवनको सिद्धान्त प्लवनको नियमलाई भेरिफाई गर्नको लागि चाहिँ प्रयोगद्वारा टुक्रालाई जोखौँ है त जोख्दाखेरि हामीले यसको तौल साह्रै थोरै मात्रै यहाँ अब्जर्भ गर्न पाएका छौँ कति छ त भन्दा 0.05 न्युटन देखिएको छ भाइ फेरि कति भयो ठुलो काठको टुक्रा भए हामीले यहाँ देखियो त भयो काठ हेरौँ है त यहाँ कति तरल पदार्थमा यो काठको टुक्राको तौल कति हुन्छ केही पानी त यसले पनि के गर्छ विस्थापन गर्छ अब जोखौँ यसलाई तरल पदार्थमा जोखौँ जोख्दा अलिकति पानी पोखिन्छ भाइ बहिनीहरूले यसलाई सजिलै अवलोकन गर्न सक्छौ कि पानी पोखिएको कुरा यो काठको टुक्रा। अब यहाँ हेरौँ, यहाँ पानी पोख्यो, हामीले हेर्न सक्यौँ र पुरै थेगियो। अब यो पुरै यसको तौल कति हुन गयो? 0।
Now see over here, the string, the wire is not straight and it's not holding any mass. So we say that the force on a floating object or the weight of a floating object is 0 because upthrust is equals to its weight. So from here we conclude that mass of an object is equals to weight of liquid displaced. That is the condition of floating object. Okay.
हुन गयो। यो पुरै के भएको छ?
Okay, let's continue from our slide. Okay, now from there we conclude that weight of object is equals to weight of liquid displaced for floating object. So that wood is the floating one, so he took a floating object over there. Now let's go down, let's solve some numericals. What is the weight of floating object? It should be 0. And also it is concluded that if density of solid is less than density of liquid, so it will float. See over here. And if density of solid is equals to density of liquid, it will be suspended somewhere. Why? Because of thrust. In this case, what we conclude is, in this case, okay, it's alright. The weight of an object is acting downward, and weight, yes, and of thrust is acting upward. So both balances. So it is suspended in the liquid. And here, if the density of solid is more, it's less, so density of liquid is more. That's why it will flow. And here density of solid is more, so it is it at the down, so the weight is more over here. Now let's solve this numerical. If 0.3 m cube meter cube volume of ice is cube of density 900 kg per meter cube is kept in a water of density 1000 kg per meter cube, find how much part of this volume is above the surface of the water. Okay. Now this is one water vessel and you are keeping the ice cube over here. Ice cube has the volume is 0.3 meters cube. So we have the this is the case of floating. So the case of floating, I told previously, this is the good formula to solve. So volume of ice, because you are putting over ice, volume mass of object equals to mass of liquid displaced. So volume into density is mass. So if you don't believe me, over here I have written this good formula. Object is ice over here, so I am writing vi. Okay, see over here, vi into density of ice equals to volume immerse into density of liquid. So 0.3 into 900, because volume of ice is given 0.3, density of ice is 900, equals to volume. How much volume is immersed? Don't know. Yes, so we are going to find that immersed part of the volume. V immersed into density of liquid. You are kept in the here. Water is written over somewhere here. Water density and molecular density you should know. So that is 1000. So V immersed equals to, you can multiply and you get 0.27 meter cube. Now what fraction is above the surface of the water? It means that outside surface, what is the volume? 0.3 minus 0.27, because whole total volume minus volume immersed. Volume immersed is 0.27, so you will get 0.03. Just how much fraction is above the water? 0.03. This is the volume above the water, and by divide by total volume, so you will get 1 by 10. Similarly, the question can be twisted. If height of 10 meter of ice cube of density 900 kg per meter cube is kept in water of density 1000, and how much part of height is above the surface of the water? So in this question also, all the area base will be generally height gives the pressure, or height is helpful. Since volume equals to area into height, the what happens, the area will always be it will emerge or submerge. So area is not necessary over here. How we can solve this? Volume means area, yes, area into height. How much height is given? 10. Yes, height of ice is given, so keep density as it is 900. Now what is the value of volume immersed? I'll not solve it detail, yeah, you should solve yourself. And volume immersed means, yes, volume immersed, yes, area will be same, area will be immersed, and how much height will immerse you don't know. Just I'm writing h over here into 1000, and a will cancel out, and how much you will get over here? This 20 and 20 will cancel, 100 cancel, 9. Height will be 9 meter. It will be submerged or immersed 9 meter. Now how much portion is left above? 1 by 10 should be the answer. I hope you understood over here. This is the volume inside the liquid, height inside the liquid, and how much is on the surface? 1 centimeter is at the surface. Then if you need the fraction means height, height outside the surface divided by total height. Yes, we will get 1 by 10. And this is the one of the questions we used to ask in grade 11. A 25 cm thick block of ice floating on the fresh water can support a 80 kg man standing on it. What is the smallest area of the iceberg? Okay. Okay, now here also floating is given over here. We use the law of flotation, and weight equals to weight of liquid distance is the law of flotation. We can also write mass of solid into accretion due to gravity equals to volume immersed into density of liquid into accretion due to gravity, because of thrust this is equals to of thrust value. So we cancel out G and G. And what is the mass over here? 80 kg main is also there, and the ice also has mass. So what is the mass of ice? Volume into density. So 80 plus area into height, this is the volume of ice, and into density. If specific gravity is 0.97, you can get density multiplied by 1000. So specific gravity is CGS unit of density. Yes, you multiply by 1000, you will get in SI. So 917, and just water is written over some fresh water, so 1000. And what you can do, 80 as it is, this both expression will go this side, and A into 0.25, 1000 minus 197, you will get 83. Just calculate A, you will get 3.85 meters square. If you keep this surface area and this much thickness of ice, 80 kg man can float on the water, river, anywhere. Now let's go down. What do you mean by relative density or specific gravity? Okay, relative density and specific gravity are the same term. Density means mass by volume, and it is defined as mass per unit volume. So kg per meter cube is unit. And relative density or specific gravity is defined as density of substance to density of water. Okay, relative density generally means density of substance by density of water. It is unitless quantity. Generally, what do you mean special gravity means? The density of substance in CGS unit divided by density of water at 4 degrees centigrade in CGS unit is called specific gravity. So overall, you can say relative density and specific gravity are same thing. Just density of substance by density of water. If you divide that value, you will get the density of specific gravity, and it's unitless quantity. Okay, let's go down. Hydrometer or lactometer. Now hydrometer is the instrument that is used to measure the relative density of a liquid. Okay, it is just relative density of a liquid or specific gravity of a liquid. Lactometer is the instrument that is used to measure the purity of milk. Okay, if this is a liquid, and you keep your hydrometer, and its base is strong, and it has a narrow tube, and here is some graduation is here, is some graduated, because to have the reading. Yes, it is caliber. Okay, some liquid is over here. Okay, this is hydrometer. Now why the base is heavy base is made? So that it will, hydrometer will be in upright position. Without any support, it will stand in upright position. Hydrometer consists of narrow long string, and base is made heavy so that hydrometer remains straight up in right position. Yes, straight up means it will be upright position, upright, not up, straight up, not it is straight upright position. So right here this time. Okay, now if the density of liquid increases, what happens if density increases? Now give your logic. If density increases, upthrust will increase, so this hydrometer will move upward. And if density is less, the hydrometer should dip more, because upthrust is less. Okay, if density of liquid is more, upthrust will be more. So upthrust more means hydrometer will float more. So if density of liquid is less, hydrometer will sink more. I hope you understood here. Now let's go down. Mercury barometer. Now I have done this mercury barometer in previous class too. Okay. Mm, I have done your previous, and here one question is like, what do you mean by torricellium vacuum? So if you keep, I told that this is one vessel, and you keep your test tube, And what happens, here is some calibration is done over here. So if you keep in sea level, this value is 660 mm of Hg, and some vacuum is created over here. This vacuum is called torricellian vacuum. So you can say, what is torricellian vacuum? The vacuum created in a mercury barometer is called torricellian vacuum. Okay, what is the relation between torricellian vacuum and the height? If height increases, then here will be less pressure will be exerted at this surface. If less pressure, this mercury will also rise less, so more vacuum will be created. Okay, this is generally mercury barometer used to measure air pressure. Now what is air pressure? You can just say the pressure exerted by atmospheric air on the surface of the earth is called air pressure. Maximum value is on the sea level, because we feel that it is the surface of the earth. And also I have written pressure is also directly proportional to access into gravity. So the pressure will varies from place to place. Okay, now at last, application of atmospheric pressure. We should learn series and air pump. There is just one we can say valve. Yes. So if always pressure, always object move from low pressure to high pressure to low pressure. Just know that one, you can read over there, but the more important is this water pump. So I'm doing just, this is the last slide. Water pump, it might take time. Okay, generally water pumps is it works on the principle of hydraulic atmospheric pressure. What are the things that based on law of flotation? Law of flotation means ship. Why the ship sink in sorry, why the iron sink in water, but the ship made up of iron float on water is, you can say in this way, iron density is more than the density of water, so it sink in the sea, in water. For the ship is made in such a way that the weight of the ship is equals to weight of liquid displaced by it, so it floats on the liquid. uh, uh, Also you can say that what happens to a boat when it floats on river water and on the ocean consists of salt, so density will increase, so it will float more. But in river water density is less, so it will float less. You can say that one also. Have you understood? Regarding river and salty water, density plays an important role. Density will be more on ocean, so if density is more, upthrust will be more, so it will float, and it will float more, and it will float a bit less in the river water. We can say that one. Okay, I think video is getting longer. Let's discuss this water pump. Okay, now see over here. Generally, water pump, you should know about two things, and it will occur in up, down stroke and up stroke. Okay, this is the underground and underground. There is one valve called valve, foot valve, and over here there is one piston valve. We call here piston valve, and next thing we call this as a rod. Okay, we call this rod, and this one is a handle. Okay, this one is we call handle. And now let's go for upstroke. Water pump applications. Okay, applications of Archimedes principle means that should be all the law of flotations applications are also Archimedes principle. Generally submarines are the example of applications of law of Archimedes principle. You can give the law of flotation example also in case of Archimedes. And law of flotation generally means ship. Okay, now ship, aeroplanes, all based on law of flotation. Now let's discuss this water pump. Water pump, it depends upon the atmospheric pressure, and there are two valves, piston valves and foot valves. And this is underground where we get water. Yes, and this is the cylinder, we call cylinder. This is called outlet, or you can call out. Okay, now in upstroke, how we call upstroke? This rod is at. So if this rod is up, we call upstroke. If rod is up, now see this rod is moving from here to here. So what happens? Volume increases. If volume increases, then we have pressure decreases. This is the one quantity set by Boyle's law. No need to mention this law over here. If volume increases, obviously pressure will decreases, and vice versa. I hope you understood. Upstroke means rod will be up. If rod will be up, handle will be down, and volume will increase. If volume increases, what happens? Pressure will be low. If pressure will be low, then water flows from underground to this cylinder. We will call this as cylinder. Okay, I should make it clear. This is cylinder. Okay, water will move from ground to the cylinder. Yes, where it is written, football. Now what is, if water comes from this underground to this cylinder, if water will come over here, then this ball, football should open and this piston valve should close. So foot valve will open and piston valve will close. So water enter from cylinder from the ground, and also the water which is above the piston will come out from the this hand pump. Okay, at the same time, if this opens, the water which is over here will come at the same time. Now what happens in the downstroke? Downstroke means the rod will go down, the handle will go up. Okay, they just move in opposite way. If this rod will go down, obviously here volume is less, so pressure will be more. So volume will be less, pressure will be more. If pressure will be more, then no water will come from underground to the this cylinder. Just what happens, the water from this cylinder will move towards this cylinder will come out from piston bulb. It will move this way, and this the cylinder is not should not be like that. The shape of the cylinder is somehow like this. It will be narrower. It goes narrower. Okay, not that much narrow also. It will be narrower. And again here piston valve will come here. Here foot valve will come. This valve will come over here. So when it moves here, the water will come out from the piston valve. So water comes out from the piston valve, and if water comes out again after downstroke, it will follow the upstroke. So water will come out, water will come inside the cylinder and come out from the outlet also, and again this downstroke will occur. I hope you understood, and this is the one of the questions uh, in asked in that model questions given by SE board. Okay, I think we complete all of the things. Just and just you can in series, just you can talk about one piston and air pump. Just one piston is over here, one valve is over there. There is two valve and two valve over here, and cylinder is over here. Just you can say that if rod is of stock and rod off means volume increases means pressure will decreases. If pressure decreases, water tries to come from underground into this cylinder. If water tries to come here, this valve is generally we use logic, this valve is open, this valve is closed. So the whichever water is on the above the piston, this will also fall out. So this is the main thing occurs during upstroke, and during downstroke this rod will go down, and this volume will decrease. Volume decrease and pressure increase. Pressure increase, this valve will be closed, and water will come from this valve to this valve, and it will come from this side because yes, this side, from here, not from this outside, not as in made over here. Water will come. Okay, that video is nearly 15 minutes. Water will come from here. Here. Okay, almost I have done everything, and though the video is long, just I am showing here. State the Newton's law of gravitation. Yeah, we have done that one. Everybody in this universe attracts is the force. This force of attraction is directly proportional to the product of masses in inversely proportional to the square of distance between their center. I told it first. Yeah. A second question: what is Upthrust? When an object is kept in a liquid, the liquid experiences upward force to the solid. This upward force is called Upthrust. Okay. Next thing we need to learn. Okay, let's go down. Okay, iron balls sink in water but not in mercury. Why? uh, as you know that the density of iron ball is more than the density of water, so it will sink, but the density of iron ball is less than the density of mercury, so it will float. Okay, now let's go down. Other questions I think we haven't learned. Okay, difference between filament length and frozen length. If you have completed that chapter, you can know from there. Now let's go down. What is over here? Okay, a meteor is going towards the earth. Let me see maths. Group C means 3 maths question. Yes. Okay, a meteor is going towards the earth. If the mass and radius of the earth have this and this, especially find the height of the meteors from which the earth's surface acceleration due to gravity is 4. Okay, if you feel this question is difficult, I can solve here. G equals to, it is talking about the height, yes. So what you can do, mass and the radius, find the mass in the, from the here, where acceleration gravity becomes, okay, quite easy one, I hope easy one. Equals to, it is talking about height, so we should write G, and since the question is talking about acceleration due to gravity, so I am using the formula acceleration due to gravity by okay, r plus h whole square. Just get the value of r. That's use mathematics over there. Everything is given. Yes, everything is given over here. G is given 4. G means you should know. M mass is given over here. There is kilometer. Try to convert this into meter. So keep it over here. This is the radius of the earth, and try to get the value of h. Okay, I want to erase. And what is the next part in the question? Okay, I cannot erase. It's more than 50 minutes. You see, the weight of the body decreases in the coal mines. Why? Okay, now I also think this might be the good question, and I have also seen this question for the first time. Why the weight of the body decreases in the coal mines? We generally think coal mine is deep inside the earth. Yes, if this is our surface. Okay, I'm just using my logic and trying to answer those questions. Coal mines are located deep here, and this is the center of the earth. So what happens generally? Radius will decrease. Yes, so situated at the deep. Okay, now we will not consider radius will decrease and this G will increase. We will not say that one. So if this is the position of coal mine, just we should think we should make one surface over here, so one circle. So we should take the mass over this surface and radius of this surface and try to find the value of G. So which will be less, since less mass is over here and radius will also less. So what we can say that this is our understanding. What we can say is weight of the body decreases in coal mine. It means that what you can say is G value decreases. So in coal mines, G value acceleration due to gravity is less, so weight is also less. Just write that answer. I think that will be easy one. But we can get G value less not by equating R only. This mass also decreases and radius also decreases. Overall G value should be decreased, and it is clear that G value is maximum on the surface. Yes, maximum on the surface of the earth, and it will goes on increasing, decreasing. Okay, if this is center of earth, and if this is the radius R, yes, if this is radius R, and this is the surface of the earth, and this is outer surface. Generally what happens, it goes on increasing. Yes, it goes on increasing, and maximum value is found on the surface. Yes, this is the maximum value, and again it will go on decreasing. This is the overall graph of excentric gravity. So if you go towards this side, G value will obviously decrease. I hope it's clear. And in center of that it is 0, and it goes on decreasing this side, so G value is maximum on the surface. I hope you could understand this one. What you can say, the weight of the body decreases on coal mine because action due to gravity decreases over there. Okay, thank you for listening. I could solve some questions also. Thank you for listening me, and please go rigorously everything I told, so that it will be helpful for you. Okay, in next class I will come up with more questions and solutions. Thank you.